So here's a steel bar with a dimension shown is a subject to an axial compression load of 265. The modulus of electricity is about 210, and the Poisson ratio is 0.3. What's the final thickness of the bar? So P over A is an equation, and I believe E equal this is an equation. Let's just hope I did it correctly. Yes, yeah. But you can always look at this chart over here to easily figure everything out. My recommendation is switch it to epsilon x because epsilon x is what we're going to be looking for. E is already given after all. And then epsilon x equal P over A E. We're already going to like a play equation almost. But um, let's have Poisson's ratio here, which equals negative epsilon yz with epsilon x. So that would mean that we can play this card, negative epsilon x equal epsilon v comma z. So you can imagine if you combine these two, so negative v p over A E equal epsilon v y, z. So you can imagine I can do that. And with that plate, we can put that into our delta. But let's just, well, let's just do it. Multiply by TO equal delta T, right? And final thickness, so it's going to be T minus delta T also equal T final also. That's the final solution. So T final is what we're looking for. My handwriting is garbage. That's why I type my homeworks. T final is what we're looking for, question mark. So we can imagine that delta t, well, there's not enough space. Delta t equals whatever that is, negative Poisson ratio P over AE over TO. Now, grab your calculators and let's do this. So we have division of negative 0.3 about. I don't like how close they are, so I can't really, I don't like how close they are. Sometimes they make it really close, so you can't round them. It's really their choice to do that, but never like them when they do it. I mean, this is it by 1,000 multiplied by whatever thickness it is, 20 divided by 1,000. Okay, we can keep everything in millimeters if we want, actually. Shall we? Yeah, why not? The reason I say that is because we should probably, I mean, I don't think the dimensions delete itself in any way that matters. So should be good. Uh, I'm just typing it in. Wow. Wow. Maybe the dimensions matter, but I get like 0.000000004. So I'm assuming it's D. I think I messed up the calculations on the dimension, dividing it dimension or something. I think it did matter to divide the bottom and top by the proper unit. So maybe I should have done that, which would have shortened it. But I think it's D from looking at this. It's 4. So if you add the original to the original millimeters, it should be that, is what I'm saying. So it's D. Yeah, hopefully. Um, Not the best way to do it, I think. I think there was a better way to do this one. I just did the shortcut and got hit by the dimensions factor of 1,000. So I probably did not make the right dimension call, which is fine. I mean, I can go back right now. I'm going back right now and just fixing that right now. I see what I have done. Yeah, so I get like 0.0000. So now it makes more sense over here. So I get negative 0.000043786. So 7, you round up to a 4, and I think that's what they did. Yeah, hopefully they did that. Assuming so, hopefully. I mean, if they didn't do that, then they have, yeah, um, not really a big problem, but you know, it's also positive. The reason why it's a positive is because over here, this is negative, this is negative. So if you have negative, positive, positive, so don't forget that. It's a compressive, so in the Poisson's ratio, it goes bigger with the thing. I didn't really care about it because I knew it was going to be adding to 20 anyways. So I just mentally looked at that and did that. But you should care about if it's compressive or pooling. This is definitely D. And we'll move on to the next question now. A steel bar with the dimensions and cross section shown is suspended vertically. Where is it shown? Uh, oh my God. Let me check the original equation again. Yeah, I'm just gonna take a picture of that and put it in here. Give me 5 seconds because this did not what's again scan correctly. All right, I got it. Here's the thing also I'll mention is that I'm starting to just take pictures with my phone instead of actually scanning it because they make too many mistakes when I scan it. I think their machine learning model like did not scan properly, and now there's like probability like curve error or something because the scanning probably device they use some kind of ML stuff, I guess, or they could be using FFT, but I don't think FFT would make that many mistakes that are personal to the numbers. The only thing I can think of that would make that many mistakes is AI. which is machine learning. So the scanning device did use machine learning. Anyway, a steel bar with a dimensions and cross section shown is suspended vertically. If you don't know, machine learning is a probability based, so it does create those kind of error because that's the only way you can make a t into a pi or something like that. Anyways, don't worry about the solid mechanics section. It is still in the form of this form, but after that, like in the fluid section halfway through, I just took pictures and used that because it was such a pain. Anyway, three consecutive downward load are applied to the bar 2250 newtons at the lower end. I see that. I see that 0 point. Okay, so it's just doing this. The modulus of electricity is 210. What is the total change of the bar? This is just a play equation on crack. So you know this equation. So you just have to say basically what you do is PL over AE plus PL over AE plus PL over AE, and it's 1, 2, 3. The area is the same, and basically the newtons are different. It's all that it wrote, basically. There's no problem with anything else. There's one thing I will mention. You have to add the force. So basically over here, you can imagine the different force from down over here. So this force is only for this block. The next force you add the second block and third and fourth. So in this case, we are so so we start over here with all the deltas over here, and how you would start this is basically, think about this. What's the max? Over here, all three forces are applied. So this is all applied. So for 1 meter, everything is applied. Now, this is going to be how you work it out. So imagine this. So P1, let's just say this distance over here, is only being applied by this. So the first thing you write should be this. I mean, it's not the first thing. You can also write the other way. And also, good catch over here on my part. 6.5 centimeters. Okay, I have to now change that to meters. Yeah, I hate when they do that to me. Anyway, cm squared, right? A neat trick about this is figure out what 100 cm equals to 1 meter, and then just square that. Do that, and it'll be good. And the E is, what is the E? I think it's 210 times 10 to the negative 9. No, no, not negative, positive 9. And then you keep on going. Okay, let's do the first one first, because why not? 2250. Why I say this? The calculator actually is bad at doing a lot of calculations at once. It starts to create error apparently, and it's not the best. So you want to split it a little bit, at least this calculator, because it's kind of shit. Is what I realized after using it for a long time. Okay, all right. You get what I'm trying to say? No, doesn't really matter. Anyways, let's just do this real quick. Da, 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 da. Oh, 0.35 also. Don't forget that. So I get this one is equivalent to saying 0.00057051. Just note that. Next one, you apply to 0.65 multiplied by 22250 plus 13500, and then divided by whatever this is, 6.5 multiplied by 1 divided by 100, square 210 times 10 to the 9. Yeah. You're bound to make a No, you're bound to make sure everything's good. So 22250 plus 13500 parentheses 6.5 times parentheses 1 over 100 parentheses square multiplied by 210 multiplied by 10 square root of 9, which is basically, it gets you to equal to 0.00017. Okay, 0238. And you have to do one last one. So this is just one. So you're just adding all of them. I'm just gonna call it a sum of all force to I because I'm too lazy to actually do it. So you just do sum of all I, 6.5, 1 over 100 square, 210 times 10 to the 9. So this is the sum of all ones. So you just plug into here, 9,000 plus, what is it, 13500 plus 22250 divided by 6.5 times parentheses 1 divided by 100 parentheses square, 210 times 10 to the square root of 9. I get 0.0000327839. So we just add all these together. Now, why do I add them all apart? Is because it makes it much easier to do the calculations on the calculator. I get 0.0055518, which I'm interpreting as B because that's the only one that makes sense. The other ones do not. So we can move on now. Oh, one of these questions. Beautiful. What's the maximum shear stress of these? Ah, yes, yes, one of these questions. So this is Mohr circle basically, and you can just go down over here, pay your respects to Mohr circle, and that's it. Basically, is what I'm saying. Mohr circle. Yeah. So here's the thing. I remember it being a half something. So I don't remember. Hmm. I think the Moore circle max just doing this portion, I believe, if I remember correctly. So as for the maximum shear stress, I'm pretty sure you just do this portion over here and you get everything. So whatever this is, you just apply it to this part of the equation. And I guess that's it. Um, Moore circle is one thing that you should try to remember what it is sometimes. Well, it depends on what kind of engineer you are, but for me, it doesn't really matter too much, I don't think. But to a structural engineer, it's king. So I'll be honest, a lot of the stuff I'm doing right now doesn't apply to my field too much, because it's not dynamic, basically. It's just in terms of FEM, maybe that's the only place I can think of that matters on this portion. But yeah, I guess that's significant amount of work on there. I guess yeah, I take it back. And so refer to this plane. So what we have to do is square root parentheses -140 and then minus is it square on those or not? It's square on the top of these. Okay, divide by 4 basically is what's saying. Yeah. So okay, it's 205 on this one, and then square this. So 2. Just keep it 2 for now, and then plus tau xy, which is going to be 100 square. And then you plug it into your calculator and it should give you the maximum, um, you know, what you're looking for because that's Moore circle. Moore circle rule says that that is your R. Um, Now, if you were trying to figure out why it does that, well, okay, I'm gonna have to explain after I get this. Um, give me a second for me to explain this after I find all this thing, okay? Right, minus 140 minus 205 divided by 2 square plus the plus 100 square. Okay. I didn't get that. Okay. So that gave me 199.4, which is about 200, which is C. So let me explain to you what's going on here. The Moore circle is kind of like this over here. Um, So when you find something over here, the tau over here is, I believe this is called the max, and this is tau min. And what happens here is that you have somewhere in the Moore circle, and you're going up over there to tau mount and tau min. Now, you can find the center of it over here, but this would only apply to C over here. It wouldn't matter to the top and end. So basically saying, yes, this is it, and that's how you solve it, is what they're saying. Because there's no way for this is a tau and end, basically, if you're trying to do it. Now, the value of doing these stress principles and shenanigans like this is because in a big scope, you could look at a tiny element and do this, and you can do it for like, I guess you could do it in FEM too, I guess. I mean, if you really want to do it there, then you can. I mean, there's no stopping you, I don't think. There's no principle in the world that says physics is wrong in that direction, in that place. Anyways, we move on here. What's the principal stress? Okay, so principal stress, all right. This one requires me to do this. Requires me to go over here and just solve this. These are the principal stress. You just solve it. Now, we already figured out the R, which is basically 200, as we discussed earlier. So we already know 200, so it's 200 plus or minus now. Now, we need to just figure out this portion over here, plus or minus 200. Now, hopefully they're spread apart that I don't have to like go into detail on what this, but I don't, yeah. Some of these questions are very specific, and I like that this one's not. So 140 is the x1, and then it's going to be plus 205 divided by 2. So let's do plus 200 first. That gave me 232. There's two of them. Gosh darn it. I should have done the other one because that was the other one. It looks like it's more diversity. All right. 127, which I'm assuming is this one. So I'm going to go with the answer that's closest, which is D. Um, yeah, I got 167, all those. So round up. That's what I did. Next question. What is the coordinate of the principal stress? Oh, God, I just deleted it, didn't I? Here's the thing. There should be an equation here. It should be arctan something here. You're seriously not going to give it to me. There's an arctan over here that they can play. I don't know why they didn't do it. Um, so this is a answer. This is the actual like 1/2 arctan, like 2 tau omega x minus omega y that they're supposed to learn in class. Um, but I can't seem to find it here. There doesn't seem to be any indication of that equation. I don't think. So we're gonna have to draw this. So I mean, what we're gonna do is basically, so what was the answer again? D? So in this place, we can figure out this line, and that line is what we're gonna look for. Is what is happening now. So we need a place like this, which we figured out. We have to tau it and then figure out the line of principle. So um, this over here should be 230. This should be 170 negative. So actually, this line should be over here. You do that. Now, what's the principal stress plane is what they're looking for, right? This one over here at this point. So we need to figure out at 205, so one of these points. Oh, I erased it by accident. 205 and 100. So these lines over here. You just have to choose one of them. You don't have to choose both of them. And then what you do is basically get the angles from here. So whatever angle over here it is, so basically, usually you have a definition over here. Do they have a definition? Which way? So 2 theta is their definition, it looks like. It looks like their definition is something like this. Figuring this angle out should give you the whole answer you're looking for. And that's pretty much it. And how you do that is basically, we already have the radius over here, which was, what was the radius of this whole thing? C, so it's 200. So this thing over here is 200, right? And from that, actually, does that even make sense? 230 minus, oh, this is minus, right? Minus is plus 170 is 400. Yeah, that makes sense. So this is 200, and you can get the angle over here by looking at it, and basically get a coordinate transfer over here to figure this thing out, which is like, why would you go the effort of doing that? I have no idea. It's usually just doing this over here, 2 tau divided by omega, and this is actually supposed to be 2 theta over here, usually. Um, I only know that because I've done this before with Dr. Chi in her class, which is why I remember these things. But it's like 2 multiplied by tau, which is 100. I think there's certain like memorization you need for this test because I'm looking at this and saying like there's no way to get the answer here without memorization here. I get about one of the answers 15, so I got negative 15, and then I guess and then it's positive 90, I guess another one. So there we go. It's D. Which makes sense. What's happening is this is all two, so this is going to be probably what they did. It's 180, and then they divide, and then 180 plus something like this thing over here is the angle. So something like this happened. And then what they did was basically divided by two, which was that 75 that they got. Uh, I'm pretty sure that's what happened. Like this is, I'm pretty sure the two angles are from here to here and here to here. They probably got like 30 over here, and they probably got like 75 times 2, just 10, 14, 150 over here, and then that's the two angles they got. Either way, that's how you solve it. And yeah, I think I'm wrong about this. I think you have to memorize certain things because there's no way that these solutions are possible without memorizing at this point. Some of these stuff you can't do physically without memorizing it. So memorize. That's what I'm learning. Anyway, a plane element of the body is subjected to a normal stress, to tensile stress in the x direction of 84000, as well as a stress of 28000. What is the principle? This is here we have a principle, same question basically. We need A, comma, single B. At this point, I'm realizing more and more we have to start memorizing some of these equations because there's absolutely no way that they didn't intend for us to memorize some of these equations, even if it's in there. And some of the equations are not in there. So you kind of have to memorize. And this is going to be the first thing I'm going to probably have to memorize. There's a few other stuff I'm going to have to write it down and memorize. And what I'm going to do is basically before the test, just refresh everything because, for example, this coordinate transformation, you can't tell me that you're not supposed to memorize this one. Minus sigma y divided by 2 cosine theta. This one, I think you're supposed to memorize. Also, this one, like, yeah, there's a real sense of you have to memorize it. I know how to derive it, like we did that earlier, but sometimes the memorization is just what you gotta do. So you plug in this into your calculator and see what you get. All right, we continue on and we get what? Delta square. I get negative 82477, which is C. So that must be the answer here. Next portion, what's the maximum shear? That is square root of parentheses omega x minus omega y parentheses divided by 2 square plus tau x y square. So the same numbers. Same thing, you just delete the font. Yeah. Just pressing back button like 300 times. We could just do minus. Oh, that might be faster. Okay, should clear that. I'll try something. Minus division, 4,600 divided by. I got like 50. I got 50500 because I got 50477. So it's D. Now this question probably won't show up, honestly. I mean, technically, I mean, it might show up. Actually, I take it back. It could show up. Yeah. So let's just. I would love this question showing up, actually. But here's the thing, there's so many questions. They would probably choose, I mean, this is the easier question, so I guess they would probably choose the easiest question possible. Here, you have to memorize another formula, 1/2 arctan. It's going to be 2 tau divided by omega x minus omega y. You can find the reasoning with the method, but I'm not doing that. I'm just going to figure it out by doing this because I'll be honest, uh, if I'm doing this test, there's like so many sections. There's like, how many sections are there? Like so many sections that it's time for you to, I don't think there is time for you to like you're gonna have to memorize the section that you're proficient on. For example, for me, I think the fluid dynamics will be the one that I have mostly memorized a bunch of them. This one, I'm gonna try to memorize a bunch of them, but this one maybe not the best one to memorize. But I get let me just double check, but it's still a good one to memorize, I guess. Your choice to memorize it, not really um something that I cared for too much. I think I forgot a negative here. I'm getting none of the answers. Okay, I'm getting 28.15, which is none of them. Oh, it's a negative, so it's going to be 90 minus that. So it's 61. 61.8, which is D. Yeah. I'm sure one of my friends that are proficient at solid mechanics, I already know who it's going to be, would be memorizing all of this internally in their head. I know who it's going to be, although I know the person that, like, I won't say his name, but he's definitely the one that's going to be goated at this. Um, and already has everything memorized. The other way of doing it was doing like some of the more circle and figuring it out. Honestly, probably if you want to make an intuitive guess, you could have done the whole entire process of doing more circle, doing the circle like this, getting the angle over here, because this thing was getting like some kind of angle, and I don't know where it is, but basically if I drew this line, you're getting this line and this. I don't, this is not equal to this. I'm just showing you what you would do for more circle. You can see what it really means to have angle between the plane over here and the minimum negative stress and the origin. Like, yeah, it's a little different than the other one, but I'm not sure why you would need this, honestly. So the wording is very important here. I've never seen a professor ask you to determine the angle between the plane of the minimum and the shear stress and the original plane of stress. Never seen that. But apparently the FE exam does it. So whatever. You can yeah, just have fun doing it. A 10 kilogram axle load is uniformly carried by aluminum alloy pipe with an outside diameter of 10 and an inside diameter of 9.6, and this is 10. The pipe is about 1.2 meters long. Young modulus is this. How much will the pipe compress? Another one of these problems with the delta basically. Yeah. Uh, a 10 kilogram axle load is uniformly carried by aluminum pipe with a height of. Okay. I don't see the big problem with this question. I think it's basically using the play again. There's yeah. But the difference is the area is different. The area is this thing over here, I think. And you're just trying to figure out the tau over here, which is basically the whole difference of this question. So if I were to give you what the question is basically saying, is asking for how much it compressed, which is delta P over L over AE. But we originally think this is a square, but in reality, it can be multiple different things. For example, if it's holding a 10 kilogram object, you multiply by 9.8, parentheses 1.2, and divide it by the area of this thing, which is pi and parentheses 10 squared minus 9.6 squared, and it is 1 over 100 centimeters squared. And then this is Young's modulus afterwards. You can choose to not believe it or not. I'm pretty sure that's how you do it. It's not rocket science, just 10 multiplied by 9.8 multiplied by 1.2 divided by pi, multiplied by parentheses 10 squared minus 9.6 squared. Yeah, parentheses, division 1 over 100 squared. Young's modulus is multiplied by 7.5 times 10 to the mega, so 610 over here. So it's going to be 10 on the top, which is about very small number. Um, Let me double check if I got everything right because I don't get any of the answers. Probably due to my incompetence in the multiplication or something typing. Um, okay, I did this. Wait, these are diameters, aren't they? Damn it. So you have to divide these by two, which the first one turns out to be 5. Second one is about 4.8, which is about 25. Okay, I get it. I got something. All right, another thing you do need to mention is divide by 2, divide by 2. Do not forget that if you, I keep on making that mistake like 16 times already. Before any question you do, check if it's a diameter or radius. I mean, it's probably because I'm sleep deprived and it's like 3 a.m. right now. But still, no excuse for that mistake. It just keeps on happening. So, okay. So a straight bar is uniform cross project as tested in tension. A bar cross section is 6.5. Oh, another centimeters. Good golly. Anyways, and a length 4. The tension load is 65 kilonewtons. The elongation is 2.5 millimeters. So the delta x equals about 2.5 times 10 to the 1000, basically. What's the modulus of elasticity? Oh, great. So it's a play equation, right? I don't think there's anything else you can say. So E equal P over L over A over 2.5 divided by 1000. So that means E equal, what is this? So 65 times 1000 multiplied by L, which is basically 4 divided by area, which is 6.5 times 1 over 100 square. And then it is 2.5 divided by 100 as in delta. So division, 65 multiplied by 1000 multiplied by 4 divided by 6.5 multiplied by parentheses division 1 over 1000, 100 parentheses squared multiplied by parentheses division 2.5 divided by 1000 and its parentheses, and that is, whoa, that's a huge number. Uh, okay. Hmm. That is none of the answer choices. I get 1.6 e to the 11. I'm gonna double check the actual original question because I can't seem to find the wrong answer here. So what is yeah, I knew it. Okay, so the mistake is not me, as per usual. I mean, not per usual. A lot of times I make a mistake. What's happening is because I mean, I check sometimes over here, and it's coming from this textbook, and I told you about how the mistakes keep on happening because of how it's transcripted. Um, I got sick of it now. I'm just taking pictures, honestly. This is actually 85 apparently. They really need to stop using those ML software, I guess. Um, that's how they scan it, I think, because traditional fast forward transform wouldn't make that mistake. E equal 2.09 times the 10 to the 11. So 11 minus 3 basically equals 9, right? 3 equals 8 actually. So that doesn't sound right then. It should be hmm. Well, no, that's right. It's minus 2 because there's 2 over here. So that means it's A. Gotcha. A solid round steel rod, 6.25 millimeters in diameter and 375 millimeters long, is rigidly connected to the end of the solid square brass rod, 25 millimeters on the side and 300 millimeters long. Okay? The geometric axis of the bar is along the same line. The axial tension force is 55.4 kilonewtons is applied at the extreme end of the assembly for steel. E equals 200 gigapascals for the steel and an E equal 90 for brass. Determine the total long ratio of the assembly. So let me think about this question. I think this question should, well, I don't know about you, but we just have to, I don't like how the question is phrased a little bit. So a solid round steel rod and originally to the end of a solid square brass rod. How would you even do this? You would have to fuse this together with diffusion. And or add if you pressed two metals close enough, they do diffuse automatically. So high pressure or a melting phase. Yeah, that's how they probably did it. But then there'll be a different compressive force in there. Okay, that's just a weird side note anyways. So elongation, we could just do PLAE, right? There's nothing stopping me from just playing PLAE 2 times here. And there's just 1, 2, and what kind of force? Axial force is about 5.4 kilonewtons, and it looks like And you might be wondering, what's the difference between a wall with 5.4 over here and not wall and doing this? Nothing, they're the same equivalent. A lot of people don't understand that. Just so you know, now you understand. Um, the math shows that they're the same, and it makes sense. If you really think about how they work, yeah, they do. I don't think there's anything special about this. This is just doing this two times and then um, just getting the answer. So it's about 5.4 times 1,000, right? Parentheses the length of this. And I need more space. Delta total equal 5.4 multiplied by 1,000. Actually, let me just erase all this because I understand what it's doing now. So there's no point in me writing this. And let me just write the whole equation down. Because why not? I was expecting it to have some kind of diagram because that would be awesome. But I guess it's not in their budget or something. Um, 375 millimeters. So divide by 1,000. Yep. Parentheses. Divided by 375. Oh, that's a long. No, that's wrong. It's diameter. Always check if it's diameter or not. You can get fucked by it real easily. And it's 1,000 square. E equals what for steel? 200 multiplied by 10 to the negative 9. I'm so happy they're not cruel and unusual where they make you go to the handout over here and go over here to this little diagram over here and make you find it. This would actually suck if they make you do this. I would like hate the test papers and they would be considered trash if I had to look at this thing and figure out, hey, what is a cast iron alloy? What is the specific? What is this? What is the percentage ratio of that? I would literally just say, you know what? This is not a test I want to pass anymore. But luckily, they're not that cruel, and they actually give you numbers. Like, imagine if they did that, like half the people there would just say, you know what, not worth it. I'm not joking. That's probably what would happen. 300 multiplied by 1,000 because you already have to look at like 16 equations over here unless you have them memorized. And that's not even all the equations you need to memorize. I will tell you this, the next question over there made me realize you have to memorize an equation and there's no getting around with it. There's no way to get around not memorizing that equation. And I'm sad about it, but you have to memorize it. You can derive it, yeah, but who wants to derive that on the test? I derived it earlier and it was like a little bit of a, you can do it, but I don't feel like it's worth it. Anyways, uh, now we have 25 multiplied by 300 next. No, not 300. Square. So it's actually, sorry, that doesn't make sense. 25 parentheses square divided by 1,000 parentheses square multiplied by what? Parentheses, the last multiplication is 90 times 10 to the 9. And this is supposed to be a plus. I keep on making minus for some reason. Not really a good thing. Just a habit I have. So division, 5.4 multiplied by 1,000 multiplied by parentheses 375 divided by 1,000 parentheses pi multiply parentheses division 6.25 divided by 2 parentheses square multiplied by parentheses division 1 over 1,000 parentheses square multiply 2,200 multiplied by 10 square root of 9. That is, I get 3.3. Okay. And do this one at a time because usually you would screw up one in your calculator because how it works is the calculator is rounding some things and when you multiply something. So this portion over here, 1, so delta 1, this is total, is about that. Delta 2 is about this over here. Let me just do it. 5.4 multiplied by 1,000 multiplied by parentheses 300 multiplied by 1,000 divided by 25 square multiplied by parentheses 1 over 1,000 parentheses square multiplied by 90 multiplied by 10 to the square root of 9, which is about, okay, I get something like this small. I don't know if this is correct, but I get something really small, which probably is correct, I honestly think. So that total gave me 0.358824 millimeters. Because the calculator gave me 0.000358884, but this 3, you go away if you multiply by 1,000, I believe. And you get 0.35, and then you round up to 0.36, which is B. With that said, the next question over here will require a memorization skill. So I have the equation somewhere over there. I'm not looking at it right now because I want to try and get it out of my head. So let's go and try to get it out of my head. So normal equal x plus omega y divided by 2 plus, minus, I believe, omega x minus omega y divided by 2, parentheses, cosine 2 theta, and then it's plus tau xy sine 2 theta. And let me check if that's true. I made a mistake. It is plus here, apparently. Other than that, that one I did not make a mistake on. And then tau xin, or tangential, equals negative apparently x minus OY, I believe, and it was the opposite of cosine, 2 theta, and then it was like, I think it's still plus xy cosine 2 theta. Let me double check now. Yeah, yeah. So you can see that I have it memorized now. I hate that we have to memorize it. I hate it. And also you might be asking, what are these angles? The angles are from 30. Do not use the one from the bottom. Yeah, I don't like this. No one likes it, but we have to memorize it. So which one are we supposed to use over here for number 8? Yeah. Okay. This is solving for basically the data x, I believe, and you just plug a chug to figure it out. Hmm, interesting. Almost stress. Yep, that's pretty much what we do, but where's 7? I think problem 7 got deleted. Um, okay, it's kind of fucked, but um, problem 7 was something. It was actually, let me check the original database on what the problem 7 was. Problem 7 was a different question. Oh, wow. For some reason, problem 7 got deleted. Okay, I'm gonna add a problem 7 by deleting these two. And then we're gonna do this right after problem 9. Did problem 9 got deleted too? Oh, wait, this was problem 9, sorry. So this gets deleted. And let me take a picture of that right now with my phone. Oh, I'll do this later. It's not even, my phone's not even. Yeah. So anyways, we have to do this one. This is problem 8 apparently, but yeah, I'll find problem 7 later. Okay, so now we can just memorize this formula and use it. So let me grab my calculator and plug all the numbers in because yeah, memorize that formula now because at this point I've been using that like 20 times and basically it's not getting any better. So use it. Just use it. Just there's no point of you not memorizing at this point. Why? I'll be a fool not to tell you to memorize it. This way is positive, by the way. So I can do a division over here. I could do 2.75 plus 8.25 divided by 2 plus division. Oh, wait, 8.25 minus 2.75 divided by 2 cosine 2 multiplied by 30 because you have to use that one. Parentheses plus tau, which is 2,200, 2 apparently. And 2 multiplied by sine 2 multiplied by 30 parentheses equal about 8.6. That's D. So we have D. So plug in that. Yeah. It's not worth it for you to not memorize at this point. So do memorize it, seriously. So we have problem number 8. What is the stress parallel to the inclined plane at a 60% from horizontal? So this is the same question over here where we're asked to basically do the same thing again. So let's see if I memorized it already. It's negative omega x minus omega y divided by 2 sine 2 theta plus, what was it again? Tau x comma y cosine 2 theta. Now, you can choose to not memorize it, but I'm going to choose to memorize it because in the future, you'll figure out that this is truly needed. 8.25 plus 2.75 divided by 2 sine 2 multiplied by 30 parentheses plus tau is, wait a second, that's true. I was about to say there's 2 of them. I was like, I didn't read that correctly. 2 multiplied by cosine 2 multiplied by 30 parentheses. Okay, that is completely not any of the answer choices. I must have made a mistake somewhere. Okay, let me just retype it in my calculator. So negative 1, negative 8.225 minus, although or I made a mistake in the writing of this, but I don't think I did. Yeah, I don't think I did. I think it's just me typing it wrong in here. Minus 2.75 divided by 2 sine 2 multiplied by 30 parentheses plus whatever tau is. Tau is 2 multiplied by cosine 2 multiplied by 30. Oh, I get negative 1.38, which I'm going to assume is correct, and which means it's A. Yeah, just memorize these equations at this point. There's no reason for you to not memorize it. For number 7, I'm going to really quickly grab the question out because I think we should do this question, basically is what I'm saying. If my phone would ever work, I need to get a new phone soon. Yeah, there's a focus issue on it, which I will. I'm gonna buy the cheapest phone possible, basically, that fits the specs of what the school needs from me. That's what I've always done. Whatever the school needs, I buy it, and then let the always buy the cheapest brand of it, basically. Never buy the most, yeah, basically that fills all the specs. And currently, it seems like I need the specs are not known to me, which one is needed. So I wish I probably need to. I'm probably gonna say it doesn't matter. But here's the question. As you can see, I've given up on the whatever software I used to like scan this in because it kept on making so many mistakes that I have just decided to just take pictures of it. I don't know what it has done, basically. I've been keep on doing it. I was like, what is going on with this? Anyways, with that said, I'm going to do this question over here. This question is a classic. Again, the same kind of idea as before, but forces instead. And this one will require me to use the same idea. So a steel bar with a cross-section area of 8.5 centimeters square is subject to axial stress force of 65 kilonewtons. Okay, we know what's going on here. Apply to each end of the bar, determine the normal stress and the magnitude of the shear stress of the incline clockwise 30 degrees from the direction of the load. So here's what we're going to do. We are going to memorize again, and in my head, let's see if I can get this right again without looking at anything. Because this test is all about being able to do this without looking at stuff, apparently, which is definitely bullshit in my opinion, but that's how the test designer made it. So we're just going to memorize it. I know there's a way to derive it. Dr. Chi has taught me this, but yeah, not worth wasting my time every time to derive it. I'm just gonna have it here and just do it. There's no point in doing that shenanigans. Let me be clear. Do not do what I usually in a if you're taking what's the right word? If you're actually doing work, do not do that. Derive everything and try to understand why this happens. I love the why it happens. Without the why, we are. What's the point of an engineering job? Is what I said a long time ago. Now I don't know because there's a lot of engineering jobs that you don't need the why for. Anyways, let me get this other one. I did not know. I mean, we're not physicists, basically what I'm saying. And then we have sine 2 theta plus tau xy cosine 2 theta. So we could do this. We could do tau, which is we need area for this one. P equal, this is x direction, by the way. P equal, once again, force divided by area, which is 65 kilonewtons divided by 8.3 centimeters square. So you need to convert that into like 65 times 1,000 divided by 8.5 parentheses 1 over 100 square. Yeah. So 65 multiplied by 1,000. 8.5 parentheses division 1 over 100 parentheses square equals about 7647058.24. That is right. So wow, that's definitely we would change to mega. So 76.4 mega pascals. What I'm gonna go with because I'm lazy and I'm not about to do some weird shenanigans for this question because I am lazy again. Um, we can yeah, 2 multiply and it's wow, okay. We need to get the angle correctly too. So here's the thing. What we did before was over here, right? So here's a take over here. Is normal plane 30 degree of the stress rotation, but so for axial plane, we actually need to like do some weird things to it. So um imagine this. We're going from this direction to this direction. That's how we got it, right? So in theory, what we have to do is from this direction to this direction again. So that's 90 plus 30, which is 120. Okay, so that is what it's going to be. So it is 90 plus 30, which equals 120 degrees. Do not forget that. That's an interesting thing about this thing. So I guess there's some knowledge you need to know that I didn't really cover until now. So there you go. I covered it now. So all good. So there's no tau over here, so we can just delete that. Okay. All right. Let's do this math now. Oh, okay. I get 19.1 for ON equal 19.1. So that's A, but let's do this one too because, good practice and all. And first of all, I mean, second of all, I mean, it's really good practice because it's very weird that you have to memorize something in a FE exam. I don't like it. To be totally true, I'm not a professional in this, but I just don't like it. I don't like how you have a handout, but you're still required to memorize stuff. It's kind of like what are you doing? But if that's the way you want to do it, I will memorize it. So problem 10 to 12. Oh yeah, I also got 39 over there, so 33. I got 33.08, so that is correct. 10 to 12 refers to a plane element shown. Oh wait, where is the question? Oh, I'll just read this thing first. The element is acting upon a combined glass material in modulus of 200 and Poisson ratio 0.727. What the hell? Weird, not necessary information here. There we go. I'll just keep one just because it's funny. Anyways, nah, I mean, I don't understand what's going on here. Why is there an extra one? So I'm just going to delete that actually. All right, what's the approximate strain in the y direction? Okay, so this is doing what we call the same thing again, I think. We're just doing this again, aren't we? Oh, we're doing this. That's never mind, I take it back. So this is given, and we have the Young's modulus over here, which is basically 200 gigapascals. We have Poisson's ratio of 0.27. We have this form over here, and we need to get EX, or EY. The easiest way is to go over here and look down over here at your matrix equations over here, and look at EX over here, and that's how you will solve it. So epsilon y equal 1 over E, parentheses omega y minus viscosity, not viscosity, one of the Poisson's ratio, plus this. And this should give you elongation in the y direction, clearly as day. Um, because it's asking for strain, and this is strain. That's the definition of strain. So let us divide by 1 over 200 times 10 to the 9, multiplied by OY, which is 430 megapascals, minus 0.27, parentheses, whatever. We have no Z, right? So we get rid of that. And we only have OY, which is negative 860, and we're done. And then it's 1 over 200 times 10 to the square root of 9. Honestly, this is one of the few times I've seen this question because I've never been, I don't think I've gotten this question often in my college career. So it is, I get this answer. Also to note over here, I actually did a slight error and did not do it times by 10 to the 6, which is why I got like 0.0000000, but I already recognize that, which is why I put this thing down. But yeah, make sure to do that. If you want the exact answer, it's still I get the same answer that you get. So let's go to the next question. What's the homological shear of the material? We can look over here. The shear of material is found by, wow, they're not even giving it to me. The shear should be given over here. Let me give you what G you're supposed to write. I don't understand why they're not giving you the G equation. Assuming this is a homogeneous equation, G can be given by something up over here, I think, then. We never used this, actually. So I'm gonna have to figure out what that is later. So where's G? Is my question. I can't find it. Um, if they don't give me the equation for G, I'm gonna be shocked because usually they do give the equation. Oh. If that's true, then there's another equation to memorize and stick in your head. But I'm so doubtful that they didn't give you it. I'm going to double check really carefully. Oh, here it is. Yeah. So for homogeneous equation, the shear stress, a shear modulus, is given by E over 2 over 1 plus vow. Plus the ratio, sorry, not vow. Yeah, if they didn't give you this, I was like, that's not likely. Shear modulus, right? So we're given E already for, equals 200 gigapascals. So we'll just keep it pascals, 200. And then 2 parentheses 1 plus 0.27 is all you need to get G. So you do 200 divided by 2, parentheses 1 plus 0.27. That's about 78.74. Again, round up to 80. They do like to round up, I guess, because it's like the 16th time I've seen them round up to like a something bigger than it is. It's really, really scary how they do that. What's the approximate shear modulus in the XY plane? Oh, really? We're doing one of these now. Shear strain, my apologies. Shear strain, that's just this. Yeah. Shear strain is equal to tau over G. And you can imagine what G was 80, and then the shear is about 850. So we could do 850 divided by the bottom. I get like 6,929, which is about, wait, that's wrong. What did I do wrong? It's division, not multiplication. Sorry, my apologies. Divide those two. That equals about, ooh, that sounds wrong too. What did I do wrong? Oh, it's gigapascals, right? On the bottom. So you have to do 850 times 10 to the 6. divided by whatever was on the bottom earlier, which is 80 multiplied by 10 by 9, which is 0. Let me erase that first. I get something like, hmm, that's, oh, this is 5. So I get 0.00687, which round up to about 7. So about D. Here's what you do here over here, 550 megapascals divided by 80 gigapascals, and that's all you have to do. So that is D. Yeah. Cool, right? Let's go to the next question. A horizontal beam carries a triangle distribution of a load AB. The horizontal beam has a mass of 148 kilograms per meter. So there's an extra weight in there. A horizontal beam carries a triangular distribution load of section AB. The horizontal beam has a mass of 148 kilograms per meter. That's kilograms. The beam is simply supported at the point B. The cantilever end BC is restrained by a thin aluminum rod CD. The aluminum rod has a cross-section area of 3.25 cm square and modulus electricity of 66.9 times 10 to the 10 pascals. What is the change of length aluminum? What I'm realizing here is the first thing you should do is actually change everything that you know to the right units. So for example, the cross-section area is 3.25 cm. So square, so multiplied by 1,000 square equal whatever. And there's a weight force over here that's going to be equal to 148 kilograms per meter. So times that by 9.8 times by whatever this is, which is 6.5 looks like. Yep. And then you have this force over here at 1, I guess, because that's how centroids works with that. So the force over here on the distribution, let's call it WS, something like that. I don't know what to call it. So it's 290 multiplied by 1.5. No, erase that. Because it's times by 1,000. This is why I wanted to do it. Times by 1.5, yeah. So you're doing this height times by this divided by 2. So multiplied by 2, half, which equals the answer, I think. Yeah. With that said, now we can do a global moment analysis on here. Now, I'll be honest, these slides actually don't have enough space for you to actually think too straight. But yeah, 217,500, 148 multiplied by 9.8 multiplied by 6.5. Okay, that is, yeah, that 6.5. I get 9,400 and that, but I'm trying to think of something real quick, which is, hmm, okay, I'm just gonna write that down, but I'm just thinking, what's the weight supposed to be? It's supposed to be the whole thing. So we're good. Yeah. Yeah, I think we're good. I just double check if I made an error in anything. I don't think I did. 3.25 multiplied by parentheses divided 1 divided by 1,000 parentheses square equal about 0.000325. That is fair. Okay. So first thing we have to do is do a moment analysis here. And moment is way stronger than sum of all forces because we can delete stuff with the moments, which is why you need to think of moments first every time. In a question with this, moment is the more powerful usually. So here we need to get this rate, that's 1 meter. Now we have to get this. What will this be? So we know this is 1.5. Let me just grab my calculator. 6 multiplied by 6 plus so 6.5, right? Divided by 2 equals about 3. So this over here is about 3.25. Okay? And I have to wait a second. Hmm. Okay, that's right. I need to do this. So 3.25 and then whatever minus that 1.5 is about 1.75 over here. So in this sense, what you can put down is this. Okay, in this equation, the moment belongs in here and about here. Let's erase it like this. This is about 1 meter, like this. And that is the triangle version, which is this over here. This will be about 1.75, and this will be where C is. I'm assuming the C is over here like that, which I hope I get something. So I'm going to do a moment on B over here. It should, yeah, be, let's go start with this one. 217500 positive 1 minus 1.75 multiplied by whatever weight that is, which is 9427.6 plus CY multiplied by 5. We should mention this is 5 equals 0. And that's the answer I'm going with. And I think that's the answer you should go with too. Okay. So let me go 217500 minus 1.75 multiplied by 9427.6. I get 201,001.7 equals CY 5. So CY equal this divided by 5. So 201,001.7 divided by 5, which is about 402,000.34 newtons. And this is not 15, this is 5, by the way. So just to be clarified. All right. With CY given, we can use we can use a play equation. Well, it took forever, but now we know that the P force here equals 402,000.34. And now we can use the play equation over here, equal delta change CD equal 402,000.34 multiplied by the length, which is 3.5, divided by A, which is I should have not deleted that. 1 over 1,100 squared multiplied by 6.9 times 10 to the 10, which is shocking that they give you in that and not use giga. Well, half the time they just use giga. Um, for each calculator has your different way of doing it. Make sure in your calculator you are writing the same right way. Okay. All right. I get an answer. I get a hmm, uh, hmm, hmm. All right, I get an answer, yes. I don't think it's right although because it is really small, but oh, it's millimeters, yeah. I get 0.00627 meters, which you could do 6.27 millimeters. And this is according to this chart, it was positive, so it's plus. So C. It is intention. Next question. Problem 4 to 5, 16 refers to the following AB illustration. The beam support is 80 kilogram vertical load applied to D. Okay, the beam is pinned to the wall at point A and is pinned to a vertical bar BC at point B. Okay. Vertical bar BC has a length of 5. Okay, and a square cross-sectional area of 15%. Why do they do this to me? Why do they always do this to me? Area of what is this? Vertical bar BC equals about 15 cm times 15 cm, which is equivalent to saying what? You can multiply this by 1 over 100 squared to get you fit okay, just okay. 15 multiplied by 15 multiplied by divide 1 over 100 square equal about 0.0225. Okay. All right. We have a number now. We have a starting number. All right. And modulus of electricity is 70 gigapascals. So I'm not going to forget that one. Such because 70 is an absurd number for E that I wouldn't really get tricked by that. And Poisson's ratio of that. But we should do it. E equal 70 times 10 to the 9. Poisson ratio is 0.35. What's the normal stress in bar BC? Well, you can imply this when you need this over here is going to be let's just draw this out to see how the force analysis will be first of all. The bars have no weight. It looks like I'm looking at this and it looks like all of them are just saying, "Hey, we have no weight," unless I'm missing something. Um, yeah, I don't think they have a weight in there, so that's cool. First thing we look at is actually not this. We're gonna actually simplify this by saying this over here for FBC. And then we're going to call this W. And we're going to call this point this way or point that way. If it might point one way or another. We're going to do BC, so we can do a moment on A, powerful tool. Do a moment on A to delete 2 AY, AX. That's A equals 0, and then this one is 6 meters. This one is 3 meters, so this is 9 meters to the weight. So we're going to do FBC, which is going to be plus multiplied by 6, and then minus 9 multiplied by W equals 0. Now FBC equals plus 9 multiplied by the weight is 80 multiplied by 9.8 divided by 6. 9 multiplied by 80 multiplied by 9.8 divided by 6 equals about, wow, that is about 1045.33. Maybe I simplified too much, most likely. Um, yeah, well, we did. Anyways, this looks like the answer. Yeah, I'm going to just say that's the answer and move on. Might have been, I think, yeah, that's, oh, wait, I did a mistake here. I saw that. Yeah, no. This is supposed to be, uh 177.2. My apologies. I wrote 8 instead I wrote 8 instead of 9 in this thing, so that made a mistake there. Anyway, we got our force BC equal 1177.2. With that said, you can now create the stress on what do I try to look for now? Normal stress, right? Yeah. I mean normal stress has to be just this F over A, right? So it's just 117.2 divided by A, whatever A was 0.0225. So this divided by 0.0225 equal about 52320. And that has to be this because it's killer, so it's D. Now I'm not deleting anything here because I have to use the same equation for like 3 other ones, so just keep the everything in place and just keep on going. If force AB is CB, what's CB? CB? What do you mean by is what? What are you trying to put down here? Oh, I get what I'm trying to say. I was about to say this violet stinks, but I guess they're rounding up this notice to this, which is fine, I guess. They do that often. So I guess you could double check it by looking at this and saying, "Ooh, that looks off." But what is the elongation of BC? So I think I got positive, right? Which oh, I only asked for the elongation, so it doesn't matter. So delta equal PA over LE, play equation. So PL over AE. So we have 1200 parentheses L, which is 5 meters, divide by the 0.225. Okay, and then multiplied by whatever is E, which is Young's modulus, times 10 to the 9, parentheses. So division 1200 multiplied by 5, 0.0225, multiplied by 70, multiplied by 10 to the square root of 9, which is, what the fuck is that? Uh, did I make a mistake? Because there's no, I get like, uh, I'll tell you what I got. 1, 2, 3, 4, 381, which is none of the answers. Oh, it's A. Yeah, A. Now let me erase all this and go to the next question. You gotta listen to my voice before I say anything because you might, yeah. So it's A, and go to the next question. If the longest share of BC is 5 mu, okay, that's greater than that. What is the change of thickness to the bar BC? Um, okay. If the elongation of the bar BC is the delta equal 5.0 mu m, that's the elongation basically. That was micropico, that's tiny. What is the change of thickness in the bar? So first of all, the secret is basically this is the x direction. So we can actually say, if we go over here, I don't remember the exact formula, but it should be down over here, this one. Because this is epsilon. So epsilon equal delta x over Lx direction. So that would mean that epsilon, the strain, multiplied by the L equals this. This is a non-dimensional variable, by the way. Dimensional. A lot of people get confused and think that's the solution, but that's not. That is basically the epsilon x. So what we have to do is delta x divided by Lx equal epsilon x. So with that said, grab your calculators because we're going to divide 5 micropicons by meters by 5. And we're actually going to do 5 multiplied by 10 to the square root of -9 because that's a micropicon, by the way. By whatever meter it is 5. Oh, the syntax error. It means it's so tiny probably that it can't. Or I just made a mistake with the minus. Okay. Oh my God, that's a tiny number. All right, I got like 0.0000000000001, something like that, like 9 ones or something. I'm flabbergasted that it's that tiny. Maybe I made a mistake somewhere. Probably not. Um, let me double check. Oh, I made a mistake. Oh, yeah. Okay, fair enough. So it is, what I did was 5 times 10 to the negative 6. It's 6, not 9. Divided by 5. I got 0.00001. Okay? And that equals epsilon x. Now, viscosity, Poisson's ratio is 0.35, which is negative epsilon yz, epsilon x. So you can imagine over here, epsilon x multiplied by 0.35 equal negative, so negative version of that, yz. So do that real quick. Multiply everything by 0.35. And then what you do here when you get that form, you have to multiply by the thickness of this, which is 15 centimeters. Yeah. So 0.15 is what I'm hearing. So, and it's negative, by the way. So multiplied by 0.15, please. And I get like 5.3. I get 0.000000053. That is probably this. But if you want to check 1, 2, 3, so that's nanometers. 53, and it's negative. So we got it, which is A. It's perfectly just A. Yeah. Look that. Next one is determine the Mohr circle that is a shear. First of all, before I even try, let's just try to think if I memorized it. Because I'm realizing this test needs a lot more memorization than I initially thought. So try to memorize. I'm pretty sure that's correct. And honestly, in this test, I'm pretty sure this one you have the formula. So this one I would chill out on the memorization. But still, it's good to memorize shit before a test. So yeah. But I got something like 20. um I got something like that. But here's the thing, I don't really trust my answer because it doesn't sound right. Um, oh, the reason why is because you need to get C first. My apologies. That's just R. That's just getting R. We need C. C is given by omega x plus omega y divided by 2. So divide that by, what is it? 30 is minus, so that's x first for 50 minus 30 divided by 2. That's about 10. Oh, and actually, this is the R I got wrong because 30 is pointing down, so you have to do 50 minus minus, which is plus. So I get like something like 44 on that part. So, oh no, I'm right the first time. It is just this. I just did a mistake here because no, this is right. But it's when I plug into my calculator, you should plug in 50 minus 30 because it's a direction squared divided by 2 parentheses plus tau, which is 20 squared. This should be the answer. Anyway, I get 45. I get 44.7213595. So I get this, which is C. Now, I doubt that will we probably will. C, as determined the most, what is the maximum normal stress of the element? Maximum normal stress? Well, here's the thing about normal stresses. Usually you find them by doing this, and the maximum normal stress is here and here. So basically that's what I'm gonna do. Um, yeah. So we already figured out 45 last time. And actually we already figured out this too, which is if you don't know, let me go check what I got. Is 450 minus 30, which equals 20 divided by 2, which equals 10. So 10 plus 45 equals 55. So it's B. With that, we're done with this section. And we can move on to the secondary section.